Hello, this is G. Ramesh Kalyan, Assistant Professor, Department of Computer Science and Engineering, SNS College of Technology. The course name is 19 CST 302, Neural Networks and Deep Learning. The topic is Vanishing Gradient Problem. So in the previous video, that is rectified linear unit, we saw a simple topic of vanishing gradient problem, that is rectified linear unit activation function is used for overcoming this vanishing gradient problem. So we saw again and again the term called vanishing gradient problem. So we'll see what is we'll see in deep about the vanishing gradient problem in this video. So initially, vanishing gradient problem is a phenomenon that occurs during the training of deep neural networks, where the gradients that are used to update the network become extremely small or vanish as they are backpropagated from the output layers to the earlier layers. So as I said in the previous video, so as the name itself suggests, the vanishing gradient problem is the situation or the phenomenon in which during the process of backpropagation from the output layer to the earlier or the previous layers, the gradient size gradually increases, and at a certain condition it becomes very small, and after that the gradient is itself gets vanished. So this point is known as the vanishing gradient problem. And this is done, this is occurred during the training of deep neural networks. So during the training process of neural network, the goal is to minimize the loss function by adjusting the weights of the network. So this backpropagation algorithm calculates these gradients by propagating the error from the output layer to the input layer. So the consequences of vanishing gradient problem include slow convergence, network getting stuck in low minima, and impaired learning of deep presentation. So if the model is suffering from vanishing gradient problem, it has the following parameters or the following conditions. So the first one is the parameters of the hidden layers change to a great extent, while the parameters of lower layers barely change or do not change at all. So the first condition is if a model suffers vanishing gradient problem, then its higher layers, so the parameter of its higher layer changes to a great extent, while the parameters of its lower layers does not change at all. There is no change in its in the parameters of its lower layers. So next condition is the model weights could become zero during training. So the second condition is the weights of the model could become um, zero during the training process. The third condition is the model learns at a particular the model learns at a particularly slow pace, and the training could be at a very early phase after only a few iterations. So this could be the third condition. So the first one is the parameters of higher layers change to a greater extent, but the parameters of lower layers do not change at all. Second one, the model weights could become zero, totally zero during the training process. And the third one could be the model learns at the particular slow pace, and the training could be at a very early phase after only a few iterations. And next one, so what are the reasons exactly for this vanishing gradient problem? So the first one is vanishing gradient problems caused by the fact that while the process of backpropagation goes on, the gradient of early layers, that is the layers that are nearest to the input layer, are derived by multiplying the gradients of the later layers. So this in this layers that are near the output layer. Therefore, if gradients of later layers are less than 1, the multiplication vanishes at particularly rapid space. So why is the vanishing gradient problem significant? So this is because the vanishing gradient problem gradients to shrink. If a gradient is small, it won't be able to it won't be possible to effectively update the weights and the biases of the initial layers with each training session. The second one is these initial layers are vital for recognizing the core elements of the input data. So if the weights and biases are not properly updated, it is totally that the entire network could be inaccurate. So these are some of the methods to overcome. So residual rest nets can be used in multi-level hierarchy. LST, that is long short-term memory. ReLU, as we saw previously, the activation layers. So batch normalization, weight initialization, gradient clipping, and skip connections, gated architectures, reduced network path, and faster hardware. So these are some of the methods that will be used to overcome the vanishing gradient problem. Thank you.